Hey, everybody. So, we're going to begin a chapter on probability. And so, the next couple of units will be about that. And today, it's all about counting. The reason we're talking about counting is because probability is defined as a fraction, which is the number of ways of doing something we're interested in divided by the total number of ways of doing something. You can write this definition down now if you'd like, but we're not really going to use it in section 12.1. We'll come back to it in section 12.3. I just want to kind of motivate why we're doing so much counting today. So, first thing, when we're defining probability, we're interested in what's called a sample space. And so a sample space is all the possible outcomes of something. For instance, if we wanted to know what's the probability in rolling a dice, then we'd be interested in what are the possible outcomes of rolling a dice. So a normal six-sided dice has six outcomes, right? 1, 2, 3, 4, 5, or 6. That's what we would call the sample space. If we were to take a coin and flip it, most coins have two sides, and there's a sample space of either heads or tails. So anyway, that's what sample spaces are. So again, in this unit 12.1, we're thinking about counting the number of ways of doing something. And so a lot of different strategies for that. Sometimes the easiest way to count something is literally to list them all, make a list and count them. For instance, how many different ways are there to pick a letter out of the word Tennessee? Well, let's count them. There's a T, or there's an E, there's an N, or there's an S. So there's 4 different letters that are possible. There's 4 different ways. A little bit more complicated. If we have a sample space that involves the first 20 digits, first 20 numbers, that is, how many different ways are there to have an outcome that's an even number? So remember, an even number is something that's divisible by 2, something that ends in either 2, 4, 6, 8, or 0. And so we've got a list of them all. Why don't we just circle them and count them up? So let's see, here's 1 and 2 and 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 different ways of getting an even number. If we wanted a number that's divisible by 5, let's see, those are the ones that ends in 5s or 0s, right? So there's 1, 2, 3, 4. 4 different ways. And then there's prime numbers. So prime numbers are a little bit more challenging, but prime numbers are numbers that can't be divided by anything except for 1 and themselves. And so let me create a clean list here, and we'll circle the numbers that are prime. So like 13, for instance, can't be divided by anything except for 13 in itself. 15 is not prime, though, because that's 3. It's divisible by 5. 17 is prime. 19 is prime. None of the even digits are prime. 2 is the only even prime digit because it's divisible by 1 or 2. That's it. 3 counts. It's divisible by 1 and 3. 5, 7, 11 is a prime number. And this is it. Every other number is divisible by something. Most of them by 2s. Some people think 1 is a prime number, and I kind of get it, but technically a prime number is divisible by 1 and itself, and that's not including 1. Doesn't matter. I'm making a big deal about something that's not really a big deal in this chapter. The point is, circle and count up how many different numbers fit that criteria. So 1, 2, 3, 4, 5, 6, 7, and 8 would work in this sample size. Some other strategies. It's quite often useful to make a table, especially when something's happening more than once. So if we were going to, for instance, roll two dice or roll a dice and then roll it again, what are the different possibilities? And so in a situation like this, it's quite common to make a table. And maybe for the rows, I have the possibilities of one die. And for the columns, I have a possibility of the other die. And then within this table, there's a lot of different things you could do. Like if we wanted to know what possible sums are there, well, then we could fill in all these, right? So 2, 3, 4, 5, 6, 7. These are all sevens. Quite common to ask a question like, how many different ways are you can you roll a 7? Well, then there'd be, you can count them, right? 6 different ways of making that happen. Or this is 12, or how many different ways are there to roll doubles? So here, these are the possibilities of rolling doubles. So again, a table makes it a really good way of organizing all of that work. So here is a question. It says, how many different 2-digit numbers can you form if you're using the numbers 1, 3, and 8? And so we could make a table for this. So we've got 3 different possibilities for the first digit. And we've got 3 different possibilities for the second digit. And so there's 9 different 2-digit numbers that are possible, right? There's 11 or 13 or 18. There's 31, 33, 38. Or there's 81, 83, and 88. Here's another example bringing up the idea of whether things are allowed to repeat or not. So 5 different numbers, and we want to know how many different 2-digit numbers are possible if numbers cannot be used more than once. So let me make a 5 by 5 table. So we've got 1, 2, 3, 4, and 5 as our tens digits, and 1, 2, 3, 4, 5 as our ones digits. And if numbers can't be used more than once, then that means these guys are not allowed, right? Because 1 and a 1 or a 2 and a 2 would be repeating a number. So that means there's 25 total possibilities, which I got by doing 5 times 5. And then if I take away these 5 options, so 25 minus 5, that would be 20 possibilities. If numbers can be used more than once, well, then these red X's are just irrelevant. And so that would just be 5 times 5 is 25. And if we wanted to know how many numbers are there where the number must be even, so that would mean the ones digit is a 2 or a 4. So if we say that these are the tens and these are the ones digits, then 12 or 14, 22 or 24, 32 or 34, 42 or 44, 52 or 54 would be the options. And we can count them. There are 10 of them, so 10 different possibilities. Here's another tool that can kind of be useful when you've got especially when you've got several different things you're trying to keep track of. So that is making a tree. Question is, how many different ways are there if you wanted to answer a couple of true-false questions? For instance, you could say true on the first question and like false on the second question and then false on the third question. That'd be a possibility, right? True, false, false. Or false, true, false. Right? So there's at least 2 possibilities. To make sure that we cover them all and don't forget some, we could make a tree. So with our first question, we could either say true or false. And then with our second question, we could say either true or false. And then with our third question, we could say either true or false. And in this situation, you would count the leaves, if you will, at the end of this tree, and that's how many different possibilities there are. So looks like there's 8 of them. But something to note with this is that the first stage, if you will, there were 2 possibilities. And then in the second stage, there were 2 possibilities each. And then in that third stage, there were 2 possibilities each. And it's not a coincidence that 2 times 2 times 2 happens to equal 8. In fact, this idea is what's called the counting principle. Yeah, big fancy word for pretty simple idea, right? The counting principle. If you've got many different stages in a experiment, I'm putting that in quotes because that sounds like a science lab, but it's not really. Just any scenario that you're trying to explore the probabilities of. If you've got multi-stages in there, and each stage along the way has say 2 possibilities, or then 5 possibilities, or then 3 possibilities, or something like that. Well, the total number of ways of getting through those stages is actually easy to find. You simply multiply all the steps along the way. So like in our last problem, each of these were 2. There were 3 stages. They were all 2 possibilities each. So when you multiply those together, you get 8. That's how many different possibilities there are. But that works even if the stages are different, if some have more options than others. So let's look at one example of that and we'll be done. So this says, how many different possibilities are there if you flip a coin and then you roll a die and finally you spin a spinner? And there's like 3 possibilities in this spinner. So if you just want your answer really quick, you can find it almost immediately by doing some multiplications. Or if you want to draw a tree, you could draw a tree. The tree would look like this. You've got heads or tails. And then after that choice, you roll a dice. And so there's 6 possibilities. So 1, 2, 3, 4, 5, or 6. And then 1, 2, 3, 4, 5, and 6. And then from each of these, you've got a 3-sided spinner. So there'd be 3 options on the end of each one of these, which I can't draw super well because I didn't leave myself enough space. But can you imagine that there's quite a few little leaves at the end of all these, right? That's what the tree diagram would look like. So how do we get how many total leaves there are quickly? Well, there were 2 possibilities here. For each of those possibilities, there were 6. So 2 times 6. And then for each of those, there were 3. So 2 times 6 times 3 would be the final answer. And that's just big enough. I think I'm going to grab a calculator. 2 times 6 times 3 is 36. So there are 36 total options. So that's the counting principle, and that's section 12.1. Good luck with your homework. Let me know if you have any questions, and we'll see you next time.